Welcome to episode 292 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
Doing just fine. I don't think I have any news to share this week. How about you?
Well, maybe just a randomness. Our viewers, listeners probably wouldn't be terribly aware of this, but my laptop that I use for my streaming and recording had been like bogging down majorly.
I think I saw you talking about this on Twitter, and we've talked about it a little bit on and off the show.
Yeah. Well, I took apart my laptop, took off the heatsink, cleaned off all the thermal grease, put it back together again, and it's working way better than it was. It seems it was just a thermal management issue from dried out old thermal grease on my heatsink.
That's good. I've never taken apart a laptop. Like, I've certainly taken apart a PC to like add more RAM or something like that, but I've never opened up a laptop. Is that difficult to do?
It depends on the laptop. One reason I always stick with Lenovo brand is because they always have official teardown manuals on their website for every device they make. So they'll tell you, take out the screws in this order and then pop the clips in this order. And you're still going to break a couple of these stupid plastic tabs because it's just what happens.
Right.
But yeah, I mean, for one reason or another, I end up taking apart a laptop within the first week that I own it, almost certainly. I either swap out the Wi-Fi
brand new
card,
laptop?
Pretty much every time. Storage, Wi-Fi, RAM, something gets swapped out within the first week. This laptop, actually, that I'm currently using came from Lenovo, not 100% correctly built.
So you had to fix it yourself. Your brand new
I'm
laptop.
like, well, I could complain, or I could just take apart the screen bezel and snap it back together myself. And I just did that within like an hour of owning it.
That's funny.
Yeah. Well, it's a thing.
Yeah. Okay. Well, at the top of every episode, I like to read a piece of feedback. I got this email from Jim Beck, and this was in reference to our somewhat recent episode on going cross-platform with Sebastian Teofil, I believe was how he pronounced his last name. And he wrote, "Hey, this was a great talk. I almost had to pull my car over when Sebastian mentioned Windows cleanups, a shared memory, when the last process using it exits. This is something I love about Windows, but another embedded RTOS, the lack of this behavior is driving us crazy. Sebastian's suggestion of using a proxy resource such as an exclusive file lock is such a great idea. Genius. We'll be looking into this. Thank you so much for this episode and all the others." And then he added, "P.S. If you can have more embedded software guests on, that would be awesome. I really want to know about modernizing our code base in a fixed memory, very long running time environment." And yeah, it's always good to talk to people in the embedded community. And our episode today, I think, is kind of on that subject, right?
It's definitely at least tangential to the topic.
Yeah. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Ben Craig. Ben is a vice chair of C++ Library Evolution in WG21. This involves prioritizing papers, running meetings, and giving the Library Evolution chair as much grief as possible. Ben is also a chief software engineer at NI, primarily developing device drivers for various operating systems, including Windows, Linux, Mac, OpenRTOS, VxWorks, ETS, Farlop, and he occasionally tinkers on the build tooling and firmware side of things. Ben, welcome back to the show.
Hey, thanks for having me.
So is there a conflict of interest if you are a chair of the Evolution Working Group and providing your own papers to it?
No, generally not. So there's enough extra people well, we've got a whole suite of LEWG chairs and vice chairs. I think we've got basically 5-ish people now. So the chair, we've got 2 vice chairs, we've got a chair and a vice chair of library incubator, and we're all switching out. So I'm not going to chair the papers that I'm contributing to, but
I just seem like it would be convenient if you could be like, how about this one get priority today?
Yeah, there's room for trying that. I don't know how successful it would be.
Okay.
Yeah, getting the prioritization, that would be the that would be the thing.
Yeah.
All right. Well, Ben, we got a couple news articles to discuss. Feel free to comment on these, and then we'll start talking more about what you've been up to as a ISO chair or vice chair, I should say.
Sure.
All right. So this first one we have is a blog post. It's on pressing on programming, and it is how C++ resolves a function call. And we've certainly talked about like a lot of the stuff going on and discussing this blog post before, but it's really nice to have this kind of spelled out with a nice little graphic that includes two sumo wrestlers on it. I don't know. This was a fun post to read. What do you think, Jason?
Well, I was trying to decide if those were sumo wrestlers or if those were characters from Street Fighter.
Definitely
be both.
Street Fighter 2 characters.
Okay.
All right. Yeah, well, anyhow. I thought it was a great post.
Yeah.
Overload resolution is one of the deep, dark areas of the standard, and it is amazing it works as well as it does.
Yeah. There's been entire conference talks and blog posts about when it fails, right?
Yep.
Yeah, and it seems like that's what inspired the author of this blog post, is that he kept running into issues where the compiler didn't know what to do. So we finally, dug deep into it and tried to figure out how this whole process works.
And when I say it's amazing that it works as well as it does, that's more of, not saying that, oh, it's brittle and it's about to fall apart. It's more of like all of those special cases are in there to mostly just make it work. But then once you get to be a library developer, you hit those corner cases.
Yeah.
I really liked the little aside that was like, and basically it was a comment that's like, and this is where Sphene comes into play and where a potential overload gets removed. And I'm like, oh, because I still feel like Sphene is like the main part of C++ that I just kind of treat like magic. Mm-hmm. And when I saw that little aside, it just kind of gave me just that one little bit of extra information that I needed to kind of fill in my gap of knowledge there.
Get to demagic it a bit.
A little bit. Demagicked. Sphene a little bit.
All right. Next thing we have, this is just a list of popular C++ bloggers, and we've talked to many of the blog authors listed here, including recently Raymond Chen, who's on the top of the list. But it's just a nice resource if you're looking for more C++ blog content to read. These are all, developers. Some of them are posting blog posts very frequently.
Yeah, it seems to be an aging list, by the way. The top one is the most recent post.
Well, that would certainly explain why Raymond Chen is at the top, since he makes a post every day, apparently.
Yeah, that's actually, I think, his goal to always stay. No, I'm just kidding.
Almost all of them have RSS feeds as well, which is the way I keep on top of a lot of these.
It's funny because pre-COVID, if you will, I forget which RSS reader, and there was a couple days a week when I would be out of the house and I'd just be sitting down and I'd flip through all of the blog posts and whatever that I subscribed to. I have not gone to my RSS reader since March of 2020. So there's just all kinds of things that I haven't seen, I guess.
Is it a change of habit that causes you to not look at it anymore?
It's a change of habit. I just am no longer doing the things that I had been doing, where I'd be sitting there bored for an hour and flipping through my RSS feed.
I have fallen behind on my podcast listening because of the lack of a commute. So there you go.
Same.
Yeah, we have heard that from many listeners. Yeah. But you didn't start your own podcast in the past year.
No, I did not. And I abuse Reddit for to pretend to be a blog platform every now and then.
Right.
As you all have covered on here a few times.
Yeah.
All right. And the last thing we have is a post from Connor Hoekstra on his blog. And this is algorithm selection. And we certainly talked to Connor about algorithms a lot. What's he going over in this one, Jason?
Yeah, Connor's blog post is mostly about picking the most specific algorithm possible given the family that starts at mismatch and goes through a JSON find and find if and all of and those kinds of things.
Right. And he has, I think, an explanation here why he thinks it's better to go with the more specific or most specialized algorithm, right?
Yeah, code's more readable that way and more succinct.
expresses intent, can be more efficient.
Yeah.
Certainly makes sense. All right. Well, Ben, I think we had you on about 3 years ago when you must have been just starting to work on the freestanding proposal. Do you want to give us an update on where you are today with freestanding?
Sure. So all the old papers are dead, but their remnants live on. So the old papers were massive omnibus papers, and much like a giant code review from someone, those are difficult to work on. So these all got chopped. So the papers have gotten chopped up into smaller, more digestible bits, and the first two chunks of them have passed design review. So one of them is P1642 Easy Utilities Ranges and something else. I don't remember off the top of it, but it's taking some of the early stuff in the standard library sections and hopefully less controversial things and getting those into freestanding. And then I've got another one on making operator new, the global replaceable operator news, not required to be there on freestanding. And so I guess this is the time to say who freestanding is for.
Yeah, I was just going to say, before we get too
definitely.
deep, maybe we should back up and go over what exactly the freestanding proposals are trying to achieve, in case you didn't listen to the previous episode.
So there's what people have used freestanding for in the past. There's what the standard says. There's kind of what I want it to be. I really need like one of those Facebook memes of what people think I do and all of those kind of things on there. But so what the standard says, both the C and the C++ standard say that the freestanding subset, or that freestanding implementations are intended to be used where you don't have support from the OS. And I've interpreted that as, okay, you're on a bare metal embedded platform. This also matches well with when you are writing code for a GPU, because the GPU doesn't have a software OS. It sort of has a hardware OS. And then when you are writing the operating system itself, when you're inside the operating system, perhaps because you're writing a driver, which is the kind of things that I do. So that's what the standard says. That's what I want to push it to where it's being useful for. There are people that have used freestanding implementations as a way of segregating the parts that go, the parts of the library that are tightly coupled to the language, so that someone can say, okay, well, here's my C compiler, and here's just like the type defs and stuff that go with it that are tightly coupled, but I'm not going to provide any of the rest of the stuff. Someone else can provide that. The standard doesn't say that's what it's for, and it doesn't do a super job at making that separation. But other people have used it for that, and I'm ruining that use case. But I'm trying to serve all of these other use cases. So yeah, targeting kernel developers, embedded, or particularly like microcontroller kind of level embedded, as opposed to special purpose PC embedded, because embedded can mean a whole lot of things. And then GPUs, those are the main things that I'm targeting. So with the paper that's adding stuff to the standard library, prior to this paper in freestanding, you didn't have std move. You would have to write it yourself. And it's not hard to write it. There's basically the code is in the standard itself, but it would be not wise for you to actually name it std move. You're not allowed to open the std namespace. So you'd have to name it something else, and then you have a lot of code that ends up being not very idiomatic. If you just see, NI move everywhere, or your company : move, that raises a lot of eyebrows, and it makes the code less portable to where you can't take something that would work in your environment that was compiled against the compiler's standard library and move it to your environment. So this helps those kind of portability cases.
Could you explain that example a bit more? Why would std move not be freestanding currently?
It just wasn't in there, so I've added it. Okay. So I'm in the process of adding it. Okay. So one of the reasons it's not there is it's in the utility header, and the utility header is huge. And so no one had necessarily gone through the trouble to audit what made sense and what didn't make sense. Historically, a lot of the stuff that was in freestanding, that people added to freestanding, was things that had that was tied closely to the compiler. And std move isn't particularly tied close to the compiler. You can write it as a user, so it didn't make the cut. But as time has gone on, some things actually are sort of tied to the compiler that didn't make it in. So like in C++20, there's a lot of the const expr new stuff. And as it turns out, there's some things in the memory header like construct at that is basically relies on compiler magic in order to do it at const expr time. There's const expr address of, which the non-const expr version can be written by a user, but the const expr one can't be. And those are both things in the memory header, and that's not in freestanding now, but my paper adds those. There's even structured bindings, which if you want to have structured bindings for your own non-aggregate type, you're supposed to specialize some std templates. But if those aren't there, you're not allowed to open up the std namespace and provide the primary templates for you to specialize. So at least in C++20, user customizable structured bindings aren't allowed. But this paper fixes those issues.
Okay.
There are more papers in the work as far as pulling in other things, like, for instance, memcopy right now isn't in freestanding. But it's not in C's freestanding either. So there should be a paper in the next mailing that covers pretty much all of the things in C that I think should be freestanding that also overlap with the C++ things.
Do you have an actual paper for the C committee as well to make changes to what they consider freestanding?
So there have been some changes to the C++ committee since Prague or in the last year. So we've got 1 million different study groups, and we added one more. So now we've got 1 million plus one. And it's a study group that is shared between the C committee and the C++ committee. So the C, I don't remember the official name, but I've been calling it the C liaison committee. They probably call it the C++ liaison committee, but whatever. And so the paper that I've got coming up that covers the C and C++ parts is targeted towards that study group. So that way they can provide their input there. But I've had very few papers where I've had thorough wording review, and writing wording for the C++ standard is pretty challenging. And I got to, relearn all of that. But for C, as part of this paper, I got a whole bunch of C wording, and it's different enough. Like, they don't have the concept of ill-formed. It's all specified in terms of undefined behavior, and they don't have synopses for all of their headers. They've just, list functions one at a time and say somewhere else, these are all the functions that go there. So a lot of wording differences.
So is there... Oh, I'm sorry, go ahead.
No, you go on.
I was just curious if there is any implementation of your proposals so far, your papers.
So a lot of the intent is that you are able to take a hosted implementation and then chop out the parts that are not suitable for freestanding. and
Right.
use the existing hosted implementation because it would work just fine. So I have that there is an existing implementation specifically for AVR processors on GCC. Paul Bendixson put that together, and he provided excellent feedback on what things were weird in the implementation, things I possibly missed. I've also taken the Visual Studio user mode STL and targeted it at the Windows kernel, just the functions that I cared about, and gotten that working if you cross your eyes just right. And I've even started on the long process of mainly because of my own time constraints, but the long process of getting tests of testing the freestanding parts of libc++ and Visual Studio in their respective environment. So there's like PRs that I've been working with the Visual Studio maintainers with to make it to where they test these kernel pieces as part of their continuous integration builds. And I think NVIDIA even has some amount of freestanding implementation for their CUDA stuff.
Okay.
So a lot of different vendors have shown some amount of interest, have shown some interest.
What are the kinds of things you said if you cross your eyes just right, you had it working? What are the problems? What are the kind of things you run into when you're trying to chop out the unused bits?
So in this case, it was more an issue with so the kernel mode headers, the kernel mode on Windows, it has its own C runtime, and it is distinct from the user mode C runtime. So it's got its own set of headers there, and they're not exactly the same as the user mode headers. And the way all of the includes are set up, the user mode, the STL is kind of expecting to run with the user mode CRT and not the kernel mode CRT. But they all share the same names for the headers. So I had to do some nasty trickery to where it's like I would build stuff into a static lib using the user mode includes, and then have my test harness stuff using the kernel mode includes, and then link them together, and it works. But it's not ideal yet. But it was enough at least to prove that it's fine to use a tuple in the kernel. It's fine to use some of the integer random number stuff in the kernel. But it also showed that it wasn't fine to use specifically like one of the random number distributions, because the backing implementation of that happens to use floating point, and it's even specified in terms of floating point, even though the interface doesn't have any floats in it.
And, you know, maybe some minor ODR violations from what you described?
Minor-ish, yeah. Some ODR is worse than others, and that's actually a decent segue into the operator new stuff.
Okay.
Okay. Why don't you tell us
So
about that?
with the operator new stuff, so on embedded platforms, you often don't have a heap. In kernel mode environments, there's not one heap that's necessarily the right heap to use. There may be like an interrupt safe heap versus a not interrupt safe heap. And there's you don't want to consume all of the memory in the interrupt safe one, but so you don't want to just default to that. But if you are in an interrupt, you have to make sure to use the right one. So there's cases like these to where there's not for a person providing an implementation, there's not a good way to provide a default operator new. So the paper that I've got, I think it's P2013, says that a freestanding implementation doesn't have to provide one by default. They can, they don't have to. Now, these operator news are user replaceable. So if in your specific use case you have a heap and you know how to talk to it, you can still provide that using the same mechanisms that have been there since C++98. So it doesn't say you're banned from using it. It's just saying that the implementation isn't going to try to guess at what you're doing. Now this ends up coming. Then you end up getting the question of what happens if someone tries to use new and there isn't a backing new. Well, that ends up being a one definition rule violation because 0 is usually not equal to 1. And to further confound things, there's this const expr new thing, and we'd kind of like to keep that working even if you don't have a runtime new. But it's really hard to specify, especially because of the issue that, okay, you label your function const expr, you call it in some places. Some of the places happen at compile time. Some of them happen at runtime. Just because you put const expr on something doesn't mean it's forced to run at compile time. So when you're looking at that const expr function in isolation, is it well formed or not? If you see the const expr function in a header, but you never call it, does that constitute an ODR use of the operator new? And you kind of want to know the answer to that because the penalty for an ODR for an ODR rule violation is that the program is ill-formed, no diagnostic required. The program is permitted to do anything it wants to at that point because it's not really, pedantically, it's not a program. But at least in this case, it's probably the friendliest ill-formed, no diagnostic required you can get because most of the time it will either be an error or do what you wanted it to do. So yeah, there's specification challenges there. And so that paper has been in front of the core working group, the specification and wording group, and that was the feedback I got. So I get to wade deep into the bowels of core wording, trying to figure out how to address that particular issue. But yeah.
So going back to the committee stuff for a moment, you had this original omnibus paper, which was just too large, you said. You split up into several papers, you got design approval on 2 of them.
Yes.
How much, assuming those 2 papers eventually make it in, how much of your original goals with freestanding does that get you? Is it 10%, 20%, and how much is left to do?
So I'll answer the how much is left to do part
Sure. Okay.
First, and I might be able to answer the first half of that. So on the library side, I'd say there's about 4-ish more papers worth of work.
Wow.
And one of them is going to be one of those remaining 4 is coming up in the next mailing, the C and C++ overlap one. Mm-hmm. But yeah, it's going to take time. Hopefully it goes faster now that I've got some initial design approval. So getting people to have an idea of what freestanding means and get the first things through the door, I think are what the slow part is going to be, I hope. Kind of like with const expr, it's like, okay, well, we've got the first, it takes a while to, get const expr into C++11, but then things start getting marked const expr more quickly once, the initial set of problems is figured out. So that's on the library side, and that's probably, if I'm guessing that's going to be 26 before the library stuff, as it stands right now, all gets in. If nothing else, just because it takes a while to write these papers and have due diligence. There was a different paper that had sort of the clickbaity title along the lines of leaving no room for a lower level language. So that one was also an omnibus paper, and that's sort of been replaced with this other sort of omnibus paper of this freestanding roadmap, to where that paper wasn't ever going to try to specify things. It was just giving ideas of directions we could go. And so this new paper talks about, the updated view of those directions, and tries to break things up into small enough pieces to where maybe someone can come along and help and get things done earlier than, I don't know, what's 20 plus, like 5 cycles along, to get things done faster than 15 years. And so, yeah, there's lots of different pieces there. And there was also feedback on the big omnibus paper of things that the committee at the time wasn't interested in trying to address, like non-lock-free atomics. The C++ committee is fine with those out how they are, even though I think they have some issues on freestanding. But that's smaller. The impact of that decision is relatively small compared to a lot of the other issues that I bring up.
I'm actually now pretty curious about that. So non-lock-free atomics, in other words, atomics that are of a certain size or shape that for whatever reason on the platform have to be implemented with an actual lock instead of using CPU intrinsics of some sort or whatever.
Right. So the reason those are a little bit problematic is that a mutex is an operating system service. Mm-hmm. You need to have a scheduler in order to make the mutex work right. You can sort of get away with saying, okay, well, I'll disable all interrupts if I'm on a single processor system, or I'll use a spin lock if I'm on a multiprocessor system. But none of those is an implementer. I don't know which one my client is going to need because when I provide my implementation, I have no idea how many cores they're going to have.
Right.
And even things like spin locks, well, if you've got interrupts as well, then spin locks can cause trouble. So there was, I'm not alone in thinking they're trouble, but there wasn't consensus, and there's plenty of areas where there's a wealth of things that I can do to improve the situation that don't involve locked atomics. So that's where I'm going for now.
Okay.
Okay. And so with this freestanding proposal, it sounds like you're definitely interested in getting some help. Is there anyone else on the committee who's been working with you on these freestanding papers?
So there have been people that have helped review and helped author a paper or two. But as far as so far, I haven't been able to rope someone into, writing the thing that I have the basic idea for. So that's where I'm asking for, where I would love for some help on these. And I think the most time-consuming part on some of these is going to be getting the implementation experience behind some of these things, because it's fairly, I think it'd be irresponsible to write the paper if I don't have any implementation experience behind this. So like one example of a feature that I think isn't that would be useful, but isn't, but I don't have implementation experience behind, would be no except blocks. So right now you can like tag a function with no except, and okay, if that's promising that the function's never going to throw, or if it would have thrown, that you terminate instead. There are cases where you've got a whole bunch of no except functions, and it's just adding noise, and you kind of forget to put it there. So having something kind of like extern C, to where you do extern C, open curly, and then put a whole bunch of stuff that you want to be extern C, and then close curly, and it applies that all across the board. You could do the same kind of thing with no except. And then the evil use case that comes along that would probably be the common use case is, well, sometimes you have a C header that didn't extern C its stuff in C++. So you'll see people wrap the header in extern C. I could very easily imagine people doing the same thing with no except, to where if this is a C header, this C stuff isn't going to throw exceptions or have exceptions thrown through it. So let me put no except around it, and maybe I'll get better code generation out of it. It's a slightly evil use case, but I think it's still valuable.
Do you actually imagine this looking like it would be like extern no accept?
I think it would be just like no accept open curly.
Okay.
I think, but that's one of those. I don't know the C++ grammar that well, and that may explode for some reason or another.
Probably.
So that's where like implementation experience would be really useful. And then you get questions about it's like, okay, well, can I nest them? And maybe I want to put a true and a false after it. So I could say, okay, most of this stuff it doesn't throw except for these 3 functions here. So I want to put like no except true there. And can you put it at class scope and all of those kind of things that someone has to think through the details on, but the big picture item is fairly easy to explain.
This is a complete aside, but since you mentioned extern C, that feature was clearly built to be useful for more than just C, right? Because it's a string. It's extern quote C. Has it ever been used for, I mean, like, is there extern Fortran? Is there extern, like, do you know?
So there's extern C++, and I believe that actually does something in the modules world. It puts things in the global module fragment, I
Really?
think.
Is that new with modules, extern C++? Is that the first time it had a meaning?
I think it's the first time it had a useful meaning.
Okay. I'm
not positive on that, though. But it had a pedantic meaning for a long time in that technically an extern C function and extern C++ function are not required to be compatible types.
Right.
So not just because of the mangling, but they're just supposed to be different. But no implementer actually does that. I have seen extern Pascal before in some compilers, but I've never had a reason to use it.
Neat.
So someone uses it, but not super useful. But yeah, maybe extern no accept is the right way to spell it. I don't know.
Maybe we need extern Rust.
Maybe. So let's see. I talked some about no accept blocks. I'm not the first person to think of them by any means. I think I saw a talk at C++ Now many years back that Michael Spencer suggested basically the same thing. Okay. So the idea has been floating around. It's just we need someone to do the legwork. And there's a whole bunch of other things like that in this paper. So one that I'll call out, given the audience, is const expert is const eval on freestanding.
I saw that, and I was curious, like, what the implications are here. Yeah.
So the hope is that so at runtime on a freestanding platform, vector and string are basically out. They use the heap. They throw exceptions. So we don't want to require them to be there by default on freestanding. But at at compile time, there's no problem there. It doesn't, cause issues with the final code. So is there some way to where we can allow them at compile time, but not require them to be there at runtime? And so the idea there that definitely needs to be, experimented with is on freestanding, allow all of the stuff that isn't specifically marked to be freestanding. If it's got const expr on it, then demote that to const eval, or at least allow implementers to say, okay, it says it has to be const expr and hosted, so I have the freedom to make it either const expr or const eval on freestanding. Right. But require it to work at compile time. Don't require it to work at runtime. And there are some detectable differences when you switch between const expr and const eval beyond just does it work at runtime. And they get into weird corner cases that I'm not as familiar with as I'm certainly not familiar enough with it to make the pitch in earnest right now. But I want to say that const eval stuff is evaluated even in unevaluated context. So like if you use a const eval function inside of a size of or something like that, it's gonna run all of that stuff there, even if size of is an unevaluated context. When things get destroyed is a little bit different. So they're observable things, but maybe they're not so observable to cause real world problems.
Right.
Interesting.
But yeah, it would let people, do their JSON parsing at compile time, configure their bare metal chip without having to have any of the string or vector stuff show up in the final runtime code. And that sounds pretty awesome to me. You get all, the power of the language without having the overhead of some of the core operating system facilities.
Just need standard embed or something so we can bring that full circle.
Yep, full circle.
That'd be nice.
So yeah, those are, I guess, some of the more visible-ish things. I guess the one in here that I think could have the biggest benefit to hosted implementation is what I'm calling link time arrays. So if you've ever dug into the guts of a C++ testing framework, almost all of them kind of do this trick to where they have a macro that defined a global object, and that global object will register your specific test function with some array somewhere, and then their main will iterate over all of those functions and run all the tests.
Right.
And to some degree, it's a little silly, because why do you need to register all of these functions at runtime? You know them all at build time. And the reason they kind of go through these hoops is so that you don't have to, is it within one translation unit, you wrote your test, you don't have to jump to some other translation unit to put the name of your test there so it can find it. The existing architecture works and lets you just add things on a per translation unit basis. But under the hoods of that global constructor, something had to take all of those global constructors, their function pointers to those global constructors, put them in some big array, and run all those global constructors before main happened. So something was already taking all of those things and getting them in one space. And so this is a pitch to expose that functionality to end users so that I don't have to run code in order to get all of those pointers in the right place. The linker will just put them all in an array to begin with. And then when I run my code, it's already there. I don't have to run these global constructors. And once you have that control to make those arrays, there's a lot of interesting things that can be done both in hosted and in freestanding. On hosted, well, there's these test use cases. It would also allow users to solve on their own the static initialization order fiasco. So they could, instead of registering just a pointer, they could register like a pointer and a priority number. And before you run all of these functions, you sort them based off of the priority number, and then you run the function. So that way you would have control over the order in which these things run. You would be able to run, if you've got a DLL, right now, global constructors within a DLL tend to run during your DLL main, or in this awkward spot to where you're underneath some really nasty OS level locks. Well, this would allow you to have all these functions, and then you could run them at the right time, whatever the right time is for you, and give you specific control over these things. And on the embedded and kernel side, it would give you control over those same kind of things, and eventually could lead it to where if we get one of those arrays for global constructors, we could have the core language facility exposed to where I could control when regular global constructors actually run.
So how do you imagine the actual interface to this looking? Is it like part of the reflection proposal or something, or?
I've got some hand wavy straw man syntax,
Oh,
and
okay.
you can tell that it's very straw man because I hijacked register, the word register, the keyword register. So I think I've got this thing to where extern whatever your type, name of your variable, bracket register, and so that says this is a link time array, and then you declare it again without the extern, but you say what goes in it in your initializer list, and you may say that multiple times, but that kind of builds up the array. But there's questions of like, how do you get the end to this thing or the size of? And so you could have a runtime size of, which freaks out some people. Or you could have, some magic type that knows the end, the end extent, like we have with initializer list. But those are some of the kinds of questions that the author would have to figure out: is what's the syntax supposed to look like, and how do you find the end?
You just brought up one of the many pain points that I have to deal with embedded Ruby is their header files have register parameters to Ruby functions.
And they're all deprecated now, and I'm sure you're getting spammed with those warnings.
Oh, yeah. Yep. Including those into C++ header, and then I have to, or into C++ compilation unit, I have to disable those warnings around it. But I mean, it's been it hasn't been deprecated for a long time. Its actual use has been nearly meaningless for decades.
Yes. Agreed.
Anyhow.
But the word was just lying around, so I had to use it in my strawman syntax.
Well, yeah, I mean, the word's there, right? We got to reuse auto, so why not register?
Yep.
Let's think, are there any other keywords that have been deprecated you plan on using in your upcoming proposal?
Well, I mean, they took export back for modules, so there's that. But no other ones were right off, and even this one's just, to give people enough code to look at to get the idea.
Oh, I know. As volatiles being deprecated, you could use that for something.
Parts are volatile, not all of it. Pay no attention to JF's clickbaity papers, or yes. Well, the titles. The papers are good, but have to see if he manages to get more My Little Ponies into the standard with his papers.
Oh my goodness!
Yeah, I think I missed that. Where's their My Little Pony?
He was requested to add some examples, I think, for some atomic stuff, and examples are non-normative. He managed to sneak in an example that mentioned some My Little Ponies.
Nice.
Yeah. So let's see.
Is there anything else you want to go over?
So while I do talk a little bit about some of the edges of error handling in this paper, I don't cover, getting rid of exceptions entirely or anything like that, because there are other papers out there that are other papers and ideas out there that can help the error handling problem in these in freestanding domains. And so I want to give them space to be successful. Whether it's the P0709, the herbceptions, and then there's an implementation strategy that is low-cost deterministic exceptions, which I've been calling Rennick exceptions after the primary author. So I'm hoping those make progress and those can be the solution for error handling, because that's certainly the biggest problem that I think freestanding platforms end up having, is that there isn't a good error handling strategy.
Right. Okay. Well, I'm sure we have lots of embedded C++ developers listening. So hopefully some of them are interested in reaching out to you and helping with this effort. Sounds like you have a lot of great ideas to make C++ better for embedded developers, but you can't do it all yourself.
Yep. And I'm glad to help anyone that, contacts me. This may be jumping to some of the stuff that you'd be asking at the end, but yeah, my email address is in the paper, ben.craig@gmail.com. You can find me on Discord, the hash include Discord. But yeah, you can bounce ideas off me. I'll review wording, champion the paper if you're not able to make it to a meeting. All of those kinds of things. Just a lot of this work is nights and weekends, and I only have so many of those.
Right.
I feel like the AVR implementation that you mentioned is particularly important or interesting to people who are curious why this matters, because if you try to do any Arduino development right now, you have basically no standard library, even like standard array, right? Unless you pull in one of these freestanding implementations, which, clearly standard array is something you should be able to do on an Arduino. So,
yep. And it also seems very unlikely that the standards committee would implement a stood array 2 that fits slightly better. So that's one of the reasons, like for the retired paper mentions for stood array, that at would not necessarily be there because at can throw an exception. But that's some of the justification for having some of these partial classes is the core idea of the class is fine. Let's just take off the little bits that aren't core to the class but are still useful.
Right.
Cool.
Well, before we let you go, we mentioned in your bio that you're the vice chair of Library Evolution. How has that been going during COVID times? Or you feel like you're making good progress towards C++23 in the committee?
Yeah. So we've been doing lots of Zoom meetings, and I think we've been making good progress. The biggest choke point so far has been that individuals' priorities have changed. So some of the things that we were hoping to have good progress on are held up some by the authors, and the hallway conversations not being there. That's been something that's been missing. But we still got. We've adjusted our processes. We're good at doing Zoom meetings now. We've got online polling. We've changed some of our process to where we can forward things through the process in a way that doesn't exclude people that are in the wrong time zones for whatever definition of wrong is. Because getting everyone in a telecon around the world that satisfies Australia time and Russia time at the same time, that just doesn't work. But we do have a polling process that takes a while, that takes a couple weeks to where people can review the minutes of the meetings, review the papers, and say whether they think it should be forwarded from library evolution to library wording. And then at the end, whenever we do the plenary votes, there's voting opportunities there as well that aren't synchronous.
That's good. All right. Well, Ben, it's been great having you on the show again today.
Well, glad to be here.
No, thanks for coming on.